Hi guys, welcome to the next episode of Dana's Learning Lab. Today we are going to be learning about a mechanism called ozonolysis. Now ozonolysis is the process by which ozone, which is O3, reacts with alkenes to form two carbonyls. So how we will begin is I have put an example on the board showing this double bond alkene, and we will react it with ozone and dimethyl sulfide. Now, we'll begin with drawing out our given molecule, and we will draw out O3 beneath it. O3 has one double bond and one negative oxygen, which has 7 electrons. And this one has 5 electrons, so it will be a positive charge. Now, we will begin this mechanism by using the negatively charged oxygen because it has a high electron density. We'll begin by attacking the carbonyl, the double bond. And now this double bond will attack back at the oxygen. So once we've attacked the carbonyl, the pi bond has attacked back, then we will expel this extra bond onto the oxygen as lone pairs. This will give us our next structure, which will look like this. The pi bond is now used to connect the oxygen, which is connected to this oxygen, and the carbonyl is connected to this oxygen, which is connected to that oxygen. Now, these are all neutral because each one has 2 lone pairs. We do not have any charges on this molecule. What we will do next is we want to separate this molecule. So what we're going to do is we're going to split this by doing a small trick that I have come up with. Is I have memorized when we split this, you will go 1 bond to bond. Next, bond to lone pair. And third, lone pair to bond. Now, this is a trick I came up with to memorize it. You may not find this in the books, but I find that it works every single time. So I will go ahead and break that bond. I want to start with this center bond, so that way we can split it like equally. So we'll go bond to bond, bond to lone pair, and lone pair to bond. Now, the resulting molecules, we will have 2, is this one here. I will do this in black, sorry. So this will be a doubly bound oxygen connected to this oxygen, which now has an extra lone pair. So this is a negative charge, 7 electrons, which makes this a positive charge because it only has 5 electrons. Now this is our first molecule that we have created. The next one is this one here, which will just be a doubly bound oxygen connected to CH3 and CH2. So after we have split these, we're going to want to connect them again. Now this ozonolysis mechanism can be one of the more difficult and complex ones because sometimes it doesn't make sense to have to split the molecule and then connect it again. But for the purposes of this mechanism, to achieve 2 carbonyl groups that are neutral, we must split them, connect them, and then split them again. Because if we left it here, we don't want these charges next to each other, which is not favorable. So the way we'll connect them again is we want to label, I notice on this carbonyl that we have a atom that steals electron density. So this atom right here is going to have a delta minus because it withdraws electron density from the carbon, which will have a delta plus. Now, once we do that, we have labeled our partial charges. We will go ahead and begin with the negative charge. Oops. So the negative charge has high electron density. So what we will do is we will use the lone pairs on the negatively charged oxygen to attack the carbonyl, which has a delta plus. So the negative charge will attack the partial positive charge. Now, once we do that, this bond will want to go back and attack this carbonyl right here. So the bond will come back and attack the carbonyl. Now we have overloaded this carbon. So since we have too many electrons, we're going to expel this bond onto the oxygen, which could use a lone pair because it is positively charged. So next, our connected molecule will look like this. We have our original one here. We have the oxygen is now neutral, connected to this oxygen right here, which is now neutral because it has still in the bond. So it's connected to the pi bond, and then it is connected to the oxygen, which is connected to this original bond here. Now, once we have done that, we need to notice that when we have connected this oxygen with this bond, we use the lone pair to attack, and then we have the bond attacking back, and now we have this extra bond right here. So we're going to draw that in like so. If it helps, you can number these carbons. Numbering them may help you figure out where they go. With practice, it will become easier and faster. So now that we have this molecule right here, we are going to want to split it again. And so, like I said, it may not make sense, but we are splitting this in order to receive our neutral carbonyls. So the way we'll split this is our dimethyl sulfide will come in. Now, it looks like this: sulfur with two CH3 groups attached. Now, it has two CH3 groups. Sulfur is neutral. Now, what we're going to do is we're going to steal an oxygen. So we're going to use the sulfur to steal an oxygen. So then, where are we going to put that bond to the oxygen? Well, we're just going to move it right over to the next one. Well, now this oxygen will be overloaded. So then we're just going to move on our bond to the one next to it. And finally, what are we going to do with this leftover bond right here? We're just going to expel it onto the oxygen as a lone pair. So it is important to note that in this step right here, we call this step 2, when the DMS comes in. And what you do is steal an oxygen, move over a bond, another bond, and expel a lone pair onto the oxygen. Now, if you memorize that, that should get you to do well every time. So what we have left here is now we have split it. So once we have split it into two separate molecules, we no longer have this oxygen right here. So now we have a double bond O, and we have this molecule right here. This has turned into a double bond, and we no longer have that oxygen attached. Now it is attached to the DMS, and how we will draw that is sulfur, a negatively charged oxygen, and then the CH3 groups. Now, it is negatively charged because we have expelled this bond as a lone pair onto the oxygen. Since this is negatively charged, 7 electrons, which makes the sulfur, if you count, Now, it used its lone pair to attack, and so now it only has one lone pair and 3 bonds. That's 5 electrons, and it wants 6. Therefore, it is a positively charged atom. Now, this is great. This is actually our final product. If you've noticed, we went from this alkene with ozone, we have connected them, we have split them again, we have connected them again, and finally we have split them to achieve our 2 neutral carbonyls, which is the goal. Yay, perfect. So now, this is what we have here, and our leftover DMSO, as we call it. So, overall, this is the complete ozonolysis mechanism. I know it can be difficult and daunting at first. I recommend practicing over and over again. This is an important mechanism in organic chemistry too, and I hope that my video has helped you understand. And if you have any other topics you'd like me to go over or questions, I would appreciate any comments. So thank you so much and have a great day.